I have Raja Nagendran here. He is CTO of Tejasoft. He is famously known as Code Doctor with his over 20 years of experience working with around 2 billion technical debt code. So he's here to present a very interesting case from Amazon. Over to you, Raja sir. And kindly keep all your questions, note down. We'll have Raja sir later and you can ask him.
Yeah, basically, I want to talk about, I think a lot of, speakers also talked about how do you handle large code. And this is where I think, one of the speaker also mentioned that, most of the enterprise applications are millions of lines of code. So how do you handle it, very effectively? And that's where it is coming out from some of our, cases where we work with the customers to recover them. This is where there is a term called, you must be seeing it as an enterprise monolith, but slowly, you will start hearing it, enterprise monoliths are nothing but monoliths. And then how to extract advantage of serverless, that's what I will talk about. So now you see the trend in the architecture also, where, everybody talked about serverless, and then, microservices, CQRS. Now slowly the trend is modular monoliths, which is actually equivalent to how do you handle large code enterprise applications. But unfortunately what happens is, whatever the technology comes, if you misuse it, it is not enough. That's what the other side of the picture is talking about. And we also heard about AWS where they talked about, serverless, actually costed them very high and they are going back to monoliths. So please make sure that, I will try to give some contradiction here. Not that serverless is bad, something else is bad. If you can take away that much information from this talk, I think, we achieved something through this. And any company, if you really, I think Vaibhav also was talking about scale. Scale is a must for every developer. In spite of, what OS and platform does, even when you are developing an application, you should worry about how do you scale your application for millions of customers when they start using it. So unless that mindset is not there, I think we end up with functionality. We keep firefighting in the production. So but NFRs, non-functional requirements, have become all the way more important these days. And if you really look at any enterprises, they have applications, and not just one application, multiple applications. And this is where, we talk about how to bring the scale using modular monoliths as well as serverless. And that is again because, you don't want to sell your premium product for one customer and then, expect him to pay the full money. We want more and more customers, and that's where, the focus has to be scalability, so that, we are able to lower the cost and bring in more and more customers. And I am talking in the context of, he was talking more at a platform level. I will talk more about application level. That way, if you really dissect, application, you have so many ways to meet the scale. Or, you may have to do not just source code. You have to worry about dependencies, what he was talking about, Spring Boot, JUnit, whatever, you use third party, you should worry about them. And then you should know how to configure them, and then how to have a hardware also appropriately, so that, you are able to scale better. So this is where comes, the terms called, monolith. So now we know the trend is definitely serverless, as everybody knows, has some, people have realized that, that's not the way to do it. But they are trying to go back from monoliths. But I would say it is neither serverless nor monolith, it is monolith. And then serverless also has, will still be relevant with the technologies like IaC. How many of you know about IaC? What is IfC? Anybody knows about IfC? Okay, I'll cover that. And then, there are some, once you code it in a certain way, Then there are ways, which actually dissect your application and deploy it either in serverless way or a Docker way. So that way, you only code once, but rest of the deployment can be handled. That's the very latest from Google. So now coming to, let's see now how do we move from, monoliths to monoliths. This is where, I think I should have put our Sriharikota Chandrayaan 3, but anyway, by that time my slides were there. But you really see that a giant thing, we should say it is not about serverless is bad and monolith is too good. But you need benefits of both. The same thing, if you want to build a Shiva at such a giant way, you cannot expect a developer to go to every part and then create eyes part, nose part. No? So you need to find a way how to dissect it. So this is where, though it looks very easy to develop and easy to deploy, easy to test, you will still face the problems of handling large code, which can be maintainable. And you can definitely, when you have a support system to build it, you need large hardware, which is also not right. It will not be cost effective from the maintenance as well as, from the hardware cost. So now a simple example of how the large files are handled in a file in any office. You see that there are certain ways of dissecting it and then organizing them, so that we are able to easily identify and then we don't have to carry all of them. So this is a very simple example where you are still a monolith, but you are able to handle the complexity well. And the same thing when it comes to software. You would see that you can partition the team by a technology, either as a front end, back end, or now you have micro front ends, which are vertical slicing. So none of them are enough if you don't adopt them properly. So now when it comes to the team, yes, we have two options. When it comes to the code, we have too many options. Yeah, the first one we know is monolith. Second one, I think we have seen the transition, SOA, where, inter-applications, how do they communicate in a unified way? And microservices, macro services is where monoliths fits in. Mini services, where, there are some business domain, payment gateway like that, you still treat them as an application, but separate them as mini services. And microservices is always the hype. And nano services. This is where actually the serverless, whenever somebody says serverless is bad, actually I think they are referring to how do you write a code so that it gets deployed in serverless, and that's called nano services. Most of the time, about function as a service, lambdas. So that way, we should always worry about. I think, whenever somebody says serverless, please map it to the code as nano service or a pico services. So this is again, another representation where you see that, same thing. If you want to both good code base and good team, then you can combine it this way. One of this, you can have team per module. And examples of that, if you want to have a general insurance in a monolith way, I think there's one application which will serve all the kinds of insurances, whether it is a house, cars. But if you want to go in a monolith way, we say, okay, I have a separate application for vehicles, homes, business, and travel. That way, if you go to mini services level, at least you set kind of policy, and then based on that, you build an application for that. So when it comes to nano, actually, that's where you correlate, you have a CRUD level up, services, which is very, very difficult to tie them up. So you can also see that, when you partition it, one is a partition and other is how do you assemble them, how do you integrate them. So that in monolith, you see, number of connections are required are very, very less. And as you move towards serverless, these connections increase. And that's the real complexity of serverless. And if you go more deeper, you will see that serverless is function as a service as well as a backend as a service. And tying them is becoming very, very complex. And I think, that's a very logical. Amazon said that as a chattiness and all. In summary, I would recommend monoliths. yeah, you should start with startups if you are really good about it. Product which is supposed to be proven. Move toward, I mean, SOA, I think enterprises are already doing it. Microservices as you scale your customers. In return, I think, the bigger way of, classifying that is 0 to 2 million, try to be monolith. And if you want to go beyond, try to be modular monolith. And then that's where, based on your revenue, you map your architecture. Don't go by hype. Now, once we know that, there is a space for serverless, there is a space for monolith, there is a space for monolith, how do we really, what are the technologies and tools which have come these days? And that's where I talk about, a non-modular application can be very, very, I mean, that a monolith which is non-modular can be very complex to manage because the dependencies, if you see, is too much. But if you can control the dependencies, that's where modular work comes in. And some of this modularity, I think most of the developers may be already aware, where at a binary level you reuse different frameworks, and that's where you see dependencies is one of the ways how you are actually becoming modular at the same time monolith advantages you are taking. I think most of you may be able to correlate it, Maven, that these dependencies are coming from for you. To use others' intelligence as a part of your application. That's a binary level modularity. And then, an application level also, if you have, multiple modules, you can recognize them by multiple POM files or multiple build.gradles. So that's also not, I mean, I think people are talking about even that is also very complex to manage. They want to get to single source. And this is the ID level also. You can see that ID also supports a lot of modules where you can define its own class paths, its own source paths. And the real trend could be that, I think the ideal thing could be you should be modular at a source code level. And we know some of those constructs already there, which is nothing but you say public. Then, at a class level, you can reuse. Protected, still constrained. Package level, still constrained. And you can have private inner. But actually, that is not enough. That's what, and I think Spring has come out with something beyond this to help the developers to be modular. So now if you really see source code modularity at a functional level, I think this is mostly at a modularity at a class level. Then you can also see modularity at a function level. That's where you see a lot of lambdas, Azure functions. All of them are trying to say, how do you be modular at a function level? And then this is where I think a lot of focus is now coming in. The traction is, I think class level and function level is, they have a limited support or they are very hard to stitch. And that's where there is something called package level modularity. Which we also know that if you have a solution where it takes orders and inventory, how do we take advantage of package level beyond public protected? This is where I'll demo you one. So this is, I think, I'm using the Spring Monolith framework, which is, I think, very latest, I think 1 or 2 years old. Which can alert you if you are actually going back to, if you are missing the connections between too many packages, and then if you have cycles, all that, if it can be controlled at a compile time, then automatically as a developer you are more safer to convert monolith application into serverless. So this is, I actually now everything is modular, so it will work. I will break the modularity and show you that, it fails to, it fails. You have a class where, I have 3 modules, domain, inventory, and orders. And we want to make sure both of them just use, inventory and orders can use domain. and we want to enforce that, some kind of, no cycles between orders and inventory. So now if I break that, I don't want anybody to use events, then you will see the same application will complain saying that it is not modular enough. So now that's what is, now beyond packaging and beyond inherited, protected, you are getting a support from Spring that, be modular, being a monolith guy. So like that, there are cycles. I can show you the I can actually correct it fast. So I just want to make sure you understand what monolith is. It is a class level, group of classes at a package level, and then they go beyond to enforce certain rules of cleanliness. So now I can actually see even the diagram, what is the dependencies. If you really see it, I have an application, both of them depend on modular. One guy listens to it, other one depends on it, directly calls it. Other is, through the event it is able to associate. That's what I think, one of the things you should, all of you go back and then start focusing on Spring Monolith package. So far clear? Okay. I can't hear you. Okay. Yeah. See, one day actually comes from, this is again a good practice after analyzing lot of products. And at the end, we are mapping it complexity with revenue scale. So otherwise, there's no point in talking about, unless you want to reach India to America, then there's some way you have to change your strategy. And all these technologies are evolved over a period of time. Trying to kill them does not mean that, the purpose was very clear that at some point the old ones were working, at some scale they are not working. So if you really see that kind of track record, not that, one is replacing other, but when the context of the business scale changes, then you have to think about something more. So that's all. Now, one side we have seen application, other side now, there are two parts to it, right? From my talk, serverless is one side and monolith. At least I hope, monoliths, all of you would have understood by now that we are trying to make the developer more modular so that he's not left and right using the API. With the intent is that, the second part, how do you manage the deployments as serverless? And that's where if you really see the hardware partitioning. So we have seen the application partitioning. Now it's the time to see the hardware partitioning. We started with servers, now VMs, containers, and serverless. And if you really visualize them, you will see that like this, where you have hardware, OS. The virtualization talks about a VM level, and containers will talk about Docker level. And the same thing you will see it much more granular way. So basically, yes, I wanted to see, to get a scale, you need two parts of it, application scale and hardware-based utilization. But though hardware utilization, can that be software at the infra side, can we do something? And that's where serverless wins. So that way, please always think about, how do we do best hardware partition and best application partition? And when it comes to the hardware partition, you will again see that, we have come to a level where we all understand YAML. You give what you want, all the dependencies related to the application as a configuration, and that's where YAML we are all know. I mean, it is trying to stitch application with dependencies with the hardware. And so we also know about what actually combines partitioning of application as well as partitioning of dependencies. That's where we know it as DevOps, and that's where you see YAML file. You will see developer side we talk about continuous integration, and operation side they want to deploy it always. And the name given for stitching in the DevOps world, can anybody say that? What do you mean by stitching of all these complex applications at scale? Okay, I think it's very popular with Kubernetes. Orchestration. So you want to make sure that you are able to remove some VMs or add some containers, whatever the way based on the load. So that's where, and I think now the trend I could see, maybe it is still 10 years advanced. You have seen monolith application, microservices, serverless, and coming to your point, we are blaming monoliths after 10 years or 20 years of using it, which means it has worked at certain point of time. And what of that context is mostly the scale. So that we know, whenever you are adopting new one, know why the old one also work, whether it has really earned enough revenue or not. And maybe the trend could be that, I don't want to even worry as a developer, I don't want to worry about whether it is microservices or serverless or monolith. Let some tools manage it. That's where the hybrid application, maybe you should go and see Solo Glue, which is trying to support multiple ways of gluing any kind of application. And yes, this is an example of YAML where you see config as a code. I think the IaC is all about infrastructure as a code. You will start coding how my infrastructure should be. Where this is where I show you an example. Instead of saying asking operations team, give me S3 buckets, 3 S3 buckets, you can actually code it like this. Why? That way, it has become hardware has become an API for you. Let me see if I can. This is the last example I have. So what this application is doing is, it is creating three buckets for me. So now you see the best part of DevOps I see is hardware has become now software, truly software, which means developers have to be much more, they have more load. They were only now worried about business logic. Now they should also know what about coding, operations logic, which is the hardware. So that we know, I think in fact, somewhere I talk about developers' role is increasing because, somewhere, it is becoming easy, somewhere it is becoming more complex. You can see now, it has actually created 3 S3 buckets. I don't know. Maybe network must be there. Otherwise, it would have not created. So that way, start focusing. If you want to be a good, modern developer, treat operations as a software requirement. No more, it is not like a hardware anymore. It is a software for you. Anyway, I think network is slow. I can also delete it with one command. And this is where Pulumi is. I'll talk about some of the latest, frameworks or, where which are the enablers of cloud as a code. Yes, these are the ones. Pulumi is one thing I think all of you should really look at it very seriously, because I know Terraform is also there, but I think it was Terraform is trying to give his own language, but now everybody wants to do it in their own language, and that's where Pulumi excels a lot, where you can write it in Java, Python, doesn't matter. And this is all evolution, but I would see DevOps in one statement, the 10 years or 13 years of DevOps. It is trying to becoming a software code, more code, not less code. And the real thing now, see, that is also people are not happy, because now I am writing a functional code, which is a business logic. I am writing a separate hardware logic, which is infra logic as IaC. But the real problem is my functionality keeps changing rapidly. And then matching these two can become a very complex. And that's where infrastructure from code comes in. So infrastructure from code is exactly about, why don't you write it as a meta instructions within the code base, so that let the tool figure out how to write a IaC code and execute it. And this is where I think, this is still very far, but it has already come. There is a lot of traction. Look at infrastructure from code, so that you are actually having a modular code at the same time, including infrastructure code. If you remove that function, you don't have to go and maintain IaC code. So delete it, it is gone. So you see that Clotho persist. It will actually knows that now it has to actually span a persistent store, and then you don't have to worry about writing an explicit infrastructure as a code. The difference between IaC and IfC is, you don't have to maintain an explicit infrastructure as a code. And these are the frameworks where you see very well. They're still infant stage. I'm not saying they're in the prime, but IaC is in the prime. But these are the frameworks I would request you to look at it, watch out on. So in all, what we want to say that is, so you have to scale your application, yes, beyond operating system, beyond frameworks. You should worry about how to deal with millions of lines of code. And that's where, still try to partition the code in a modular way, in fact, the good trend, we also have heard about mono repo, but people also are talking about mono build, which means you just have one build.xml or pom.xml or build.gradle. Because see, unless you really control the code properly, there is no way you can achieve the scale optimally. So worry about partitioning, worry equally about stitching. And the stitching part is actually infra part, where you should see how you can write it as a program rather than as a configuration. See, I know people always said DevOps is configuration, but that is not enough when you really have a complex code. And the last part of the stitching, I think what Google is trying to do is give me a monolith modular code, which which has got very clearly defined what it consumes and what it needs. I will deploy it the way I want. And that's where you see they say that you give me module A, module B, and then I will decide how to deploy them in any cloud in any way. So Google Service Weaver is actually a 1 month old, I think. Maybe, I don't know, internally if they had more. But I think the industry is moving towards making either deployment. I think developer don't have to worry about deployment, but if you follow certain rules of monolith. So you can deploy it on one machine, you can deploy it on multiple machines or multiple processors. Let the tool handle that for you. So in all, what you should take from this is develop and debug as a monolith. I think start with monolith and try to refactor it towards monolith, and let the infrastructure be handled by IfC, and then let the tools do the rest. That's what I have. So any questions? So far.
As soon as our audience saw us, they knew I'll not allow them to ask questions. But
Sure.
kindly please note all your questions. Raja sir also will be in at the Bangalore stall. Do bug him. Thank you, Raja sir.